Hello everyone. Today we are going to see partial shadowing effect of solar PV using bypass diode through MATLAB. Just for that we have to open MATLAB and then click on Simulink and then create model. This will be our blank model where we are going to work, where we are going to design, and then click on library browser. From library browser we can call PV, just type PV, then you can get this. Then right click, add block to model and title, because till now I didn't save that model, so we can go to the untitled. Here this is one of the way to collect elements or tools to the platform. Okay. We have another way also, that is just double click on it on the screen and then write your tool's name. Power GUI, just I can get Power GUI, and then we are going to do partial shadowing effect. For that I am going to take a 4 PV array, and then I am going to take a diode, bypassing diode, and a switch on. So now I am going to set the configuration of the solar PV. So I am going to take one parallel string, and then series connected modules per string will be 1. Here I am going to choose user friend, user defined, and then here it will be 54 cells per module. Okay, and then here the voltage will be open circuit voltage will be 32.9, and then short circuit current will be 8.29, and then your voltage at a maximum power point is 26.4, and then maximum at a maximum power point the current is 7.35. Then give apply and OK. Just I need to take a 4 arrays, 1, just right click and drag it, it will be copy and paste. Okay, I'm going to connect all the things. Connect. And then call meter, means current measurement. Connect with this. I'm going to connect here, and then just complete this circuit first. And then I need to get a resistor or LC branch series, and that I can change it into resistor. The value would be 200. For an example I am taking. And then control R for rotating this resistor. Keep this, and then connect here. Then I need to get voltage measurement, so you can connect voltage measurement. So this, and then I need to get a diode for bypassing, and then one IGBT switch. Just rotate it, rotate. Collector will be connected here. It will be in reverse bias. So control R. Okay. And then you have to connect with this. Just double click, and then here just uncheck this show measurement port. So measurement port will be gone. Okay, and then I'm going to take this diode and this one. Just connect here, and then connect with this. same thing I'm going to copy and I'm going to paste here. Delete. And then just connect with this, right click and drag, you can get a new one. Open it here. So now the important thing is I'm going to use switch. Just go for this. Here you can find switch. You have to take this rocker switch to turn on and off. Okay. So we got the switch. Why we are going to get the switch? Actually, I am going to use constant to give gate signal. Constant. So I am giving gate signal here. And then same thing, power switch. And we take constant, switch, constant, switch, and constant. Okay, for gate pulse. Just controlling gate pulse, I have to take the switch. Nothing else. Okay. So how can we connect this to this one? This is the input. We are going to input to the IGBT. I am going to control this. How I am doing? Just double click on it. You will get this. Then you have to select this. It would be link. Then you have to select this one. Okay. Now when it is on, it will be 1. When it is off, it will be 0. Okay. Apply. OK. Okay. Same thing we have to do for this also. Okay. Now you can see when I am clicking on it, if I am clicking here, it would be 0. You can see here. 1, 0, on and off. That's it. Okay. Now I have to give a radiation and a temperature. For that I have to call a constant. So constant, and then give here as 1000. Apply. Okay. And then I have to give to this. Okay. And then we have another constant. The circuit diagram is for partial shading effect. So 500, 100, whatever maybe you can do for checking this. Then we have to give temperature also. I am taking here 25 degree. It's common for all. So I am going to connect all the cables. Then wait here with this. Now I am going to run this. Before that, we have to call displays to see the values. Display. So one is for voltage, one is for current measurement for this branch, another one is here with this branch, okay, and then one is for power. Connected. Now I have to call product to measure power, to calculate power. So now I'm going to run this. You can see here current value is 1.555. The output voltage would be 62.21. Here this branch current is 0.311. Then the power would be 19.35 watt. Okay. Now there will be a lot of combination. Now this switch is off. Now I am going to turn on this switch, and then I will turn off the switch. Means gate pulse I am not giving to this IGBT. Okay. And then I am going to turn off this. Okay. Now see the value. Okay. Same value you can find. Okay. Each and every one. Any combination if you are going to use, you will get a same value. Now I am going to turn on this. I am going to turn off this one. Okay. You can see the same value. Okay. And then I am going to turn on this. And then I will turn off this one. Okay, it's called shadowing effect. Means we have to get a constant voltage to the source. That's why if any cases, anything if you are going to change, you will get a constant voltage and the constant power. That's why we are using this. If you are going to change this irradiation into 500, that voltage will get different value you will get. Just see here. 16.16, 0.32, sorry, 0.16, 0.32. Then you can see the voltage 64.65. Here you can see this 20.9. This is called shadowing effect. This is all about today's lecture. So we will see in next video. Thank you guys. Thank you very much.